Graphing systems of linear inequalities. In this video, we're going to graph a system of linear inequalities. So here are a few things you need to know about graphing linear inequalities. Well, first of all, the inequality symbols less than or equal to, greater than or equal to. If you see those in the equation, you're going to sketch a solid line. When you see less than or greater than without that line underneath, in other words, it does not have that or equal to component to it, you will sketch a dashed line. Another thing you need to know is that if you're going to use the test point method, you will always shade the true side, never shade the false side. Now, the solution to graphing systems of linear inequalities is going to be the overlapping region. In other words, the part that you shaded twice. So let's do an example. Here we're given two equations here. The first one, a linear equation, x plus y. Is less than or equal to 1. So we know that when we sketch this line, because you see that or equal to component there, that means we're going to sketch it with a solid line. So let's go ahead and first get our line. We can simply get that by just using our x and y intercepts. So for example, if we cover up y and let y be 0, you can clearly see that x will be 1. And if we cover up x, we can see that y will be 1. Okay, so what we call that is the x and y intercepts. Again, you let one variable be 0 in order to solve for the other variable. So I'm going to go ahead and sketch that. And that would be 0 and up 1 over 1 stay there at 0, and then sketch my line. So now I have to decide, am I going to shade to the left of that line or am I going to shade to the right of that line? Well, since the line is in standard form, I'm going to use the test point method using the test point 0, 0, which is located right there in the point of origin, which is on the more or less left side of the line or the lower region. So what that means is I'm going to remove the variables and replace them with 0. When you get it to where you have one number on one side and one on the other, you're going to read the statement. This statement says that 0 is less than or equal to 1. Well, let's look at the first statement. 0 is less than 1. Well, that is true. 0 is less than or smaller than 1. Now, 0 is not equal to 1, but remember, with inequality statements, it means that one of the two statements is true. And since at least one of them is true, it means that this is a true statement. Recall that this is our test point area, so if we get a true, which we did, that means everything on the side with that test point is true. That's my true side, and so we shade our true side. Our next graph is, as you can see here, whenever you have just one variable, that sort of indicates you're going to have either a horizontal or vertical line. In this case, it's a vertical line. Anytime you see x equals or x is greater than or less than, that's some vertical line. This line is passing through the x-axis right at 1. So it's a vertical line passing through the x-axis right there at 1. And what type of line am I going to sketch? Well, looking at the inequality symbol here, notice you don't have a line underneath there, so that means you're going to sketch a dashed line. And so now that I have my vertical line here, my next step is to decide, am I going to shade to the left of this vertical line, or am I going to shade to the right of the vertical line? Well, we can look at the inequality statement in the original equation here. It says we're going to shade all values of x that are greater than 1. So would the left side of that vertical line be greater than 1? Or would the right side of my vertical line be greater than 1? If you said the right side, you are correct. So let's go ahead and shade that side. Now, when you are graphing systems of linear equations, your solution is the overlapping region. In other words, it's the region I colored red, and I also colored it blue. So red and blue makes purple, so it's this purplish region that you see here. That is where our solution lies. Now, the other parts sort of help you arrive at your solution, the red only and the blue only, but it is not part of the solution. So in fact, when doing your homework into my math lab, you will need to get the eraser tool and erase the red part only and the blue part only before hitting the submit button. Otherwise, it will count it as wrong. So the little purplish triangle that you see, that should be the only shading that you have on your paper. Now your lines will stay there, but the only shading is just the triangular shading. And there you have it. So here is what your finished graph looks like.